But not only do we have slope-intercept form, where again the m is the slope and the b is the y-intercept, we can also write an equation of a line if we're given a slope and any point, x and y. We use a formula called point-slope form because you were given a point and a slope. The thing that we will do for this, there's actually a little step before you just write the equation. We're going to label the x and the y, x1, y1, because they're the first point that we are given. And then when I'm writing the equation is y minus y1 equal to m times x minus x1. And all you have to do is plug the numbers that you get for slope, m, where the m goes, and the numbers for the points, x1, y1, into the point where it says x1, y1. Like you're just putting stuff where it belongs, and we're writing equations of lines. We've used this one before as well. Maybe not as much as the first one, but we have used that equation before. The third way you're going to be asked to write an equation is if you're just given 2 points. So look, oh look, they labeled it for us, x1, y1, and x2, y2. Why do you think I use the 1s here and the 2s here? Like, why do you think that's a good notation? Why? To put a 1 and then a 2. How many points did they give us total? 2 points. So if we label them, we have our first set of numbers and our second set of numbers, which is why we use the x1, y1, x2, y2. Now, there is a formula for slope, which we can use to find the slope and then write the equation like we did before. The equation for slope is m equal to y2 minus y1, so the y's are on top and we're subtracting them, over x2 minus x1. Does that formula look familiar to you? Yeah, we've used that one before. That gives me a number for slope, and then I can go back and use point-slope form, which again is y minus y1 equal to m times x minus x1. The formula just from right above it. So no matter what pieces of information I'm given, there's a process to write an equation. We're doing all of this by hand at first. You have a calculator to be able to do arithmetic, but in a little bit I'm going to teach you how to use that calculator to start and stop, like totally doing all of this in the calculator. So hang on with me for by hand and then we'll get to it with technology. All right, so for our examples here, we're going to use the graphs to write an equation of the line and then talk about or interpret the slopes. So let's look at this first one. First things first, what is this graph talking about? Like, what's the title of the graph?
Use the graph to write in
No, the
cell phones.
Cell phone use, yeah. Cell phone costs, right? And what are we measuring here? What is the x-axis labeled?
Number of text messages sent.
And then what is the y-axis labeled?
Cost dollars.
So we're looking at how many text messages you send compared to how much it costs. Now this might be a foreign concept to you because believe it or not, back in the day you used to have to pay per text message that you sent. And it was wild. My brother and I got in so much trouble when we were in high school because he got a girlfriend and started texting her all the time, and then we were 500 text messages over the limit, and then we had to pay our parents back. It was a hot mess. It was like a good $100, and when you're in high school, that's like, I didn't work because I was 14. It was wild, but you had to pay per text message that you sent, right? That's wild. Now it's all unlimited. It's all over Wi-Fi. I get it. This is a foreign concept to you, but you used to have to pay per text message that you literally sent out of your phone and received into your phone. Crazy. Okay, so what we're going to do in this situation is we're just going to decide which of the versions of the equations of a line that you wrote about earlier we can use. So what are we given for this particular problem? Are we given the slope? Are we told this number means slope? No, so we are going to have to find slope. But what are we given right here? What is this? The y-intercept. So we were actually given the b value. What number am I going to use for b? 50. Yeah, great. I already know what my b value is going to be. All I need to do is find the m, or find the slope. The b is going to be 50. That's our last piece that we need, is just to find the slope, because we can write slope-intercept form. To find slope, it's going to be like the last example we wrote down, where we need an x1, a y1, an x2, and a y2. And look, I have 2 points there, so I'm going to be able to find the slope. Now, it's good practice, especially in upperclassmen classes, as you get to more complicated formulas, to always start by writing down the formula first, especially when we're learning. So we're going to rewrite that formula, y2 minus y1 over x2 minus x1. Because when you're looking back at your notes, sometimes you're like, where the heck did this number come from? Here's where it came from. This is the formula we're plugging into. But we have all of those numbers. Y2 is 51. Y1 was 50. X2 is 10. And X1 is 0. I'm just reading it straight off the graph. I've already labeled them, so boom, they know where they're going. I'm going to give you 1 second in your brain or in your calculator. I'd like for you to reduce this number for me and give it back to me as a fraction. Okay, what'd you get as the fraction here for slope? 1/10. All right, so we have our slope number, 1 over 10. That means that we're rising up 1 and running over 10 if we were to be graphing this. If we put this in terms of a decimal, because I know sometimes we think better in decimals, that's the decimal 0.10. Now that's important for this question because we're going to eventually interpret this slope. But the moment that I have both a slope, 1/10, and a y-intercept, 50, I can write the equation. All we're filling in is y equal to mx plus b. Once I have the m, which I do now, and once I have the b, which we read off the graph, I'm going to be able to write this equation. It's y equal to 1/10 x plus 50. That's the equation that best describes this graph. Now it does ask us again to interpret the slope. We have to think of in terms of what we're measuring here. What were we measuring again on the table?
The number of text messages.
Number of text messages versus cost. What do you think the slope of 1/10, which again is 0.10 or 10th of a dollar, 10 cents. What do you think that means in terms of this slope?
The cost.
The cost. How much does it cost per text message? 10 cents, yeah. So, okay, this little symbol I wrote right here is the word therefore in math. It's 3 little dots. That's just telling you I'm drawing a conclusion here. Therefore, each text message costs 10 cents. Because that's what the slope is, which is about the price we used to pay per text message to send our text messages. It was a wild concept back in the day. You also paid for your minutes and your texts. There was no data on phones. It's the Wild West. All right, second example here. We have another table, another graph. What is this one explaining? What are we learning about here? What's it titled? Math homework grades. What is the x-axis titled?
Completed assignment.
And what is the y? Okay, so we're looking at the relationship between the number of completed assignments that you turn in and your homework grade. Wonder what's going to happen when you turn in more assignments. Let's find out. What information has been given to us in this problem? Do we have a slope given to us? No, we can find it though. Do we have a y-intercept given to us?
Yes.
I mean, can you tell exactly what number that is?
Yes.
What number is it?
87.
See, we all have different opinions. So, okay, we weren't exactly given the y-intercept though. This one we were, like it was a whole coordinate point, right? We can't be 1000% sure here, so we didn't get the y-intercept, but we did get 2 coordinate points. No big deal. I can still do the whole problem this way. We're going to look at like the third example when you wrote it down, where we found the slope, then we plugged it in. This is going to be different than the one before. So this is x1 and y1, x2 and y2. It doesn't matter which one you label which. I just like starting from left to right, labeling mine 1 and 2. If you chose the other way, honestly, same. It's fine. The two things we need for this question, because we're going to be filling in point slope form, is a slope, which we don't have yet, and then a coordinate point, which we do. Our coordinate point is 10, 85, where this is x1 and this is y1. Those are the things we need to write our formula this time. So we're going to do what your partner explained to you just a second ago. We're going to use that formula for slope. And again, because it's good in your notes to really make sure you know what you're doing, we'll write down the equation first. y2 minus y1 over x2 minus x1. Then we can plug in the numbers that we already have labeled. y2 is 95. We're going to subtract y1, which was 85. x2 is 20, and we're going to subtract x1, which is 10. We would use our brains or our calculators to reduce this. 10 over 10.
So it's a 1.
So it's a 1. It's 10 over 10, which, yes, reduces to the number 1. So my slope is the number 1. Fabulous. It's all stuff we've done before. But this time, we're not going to fill in y equals mx plus b because we weren't given the y-intercept. We're going to fill in y minus y1 equal to m times x minus x1. But don't worry, we have all of those parts. If we fill them in, it's y minus 10 equal to 1. X1, yeah. Bro, you're so right. That's so embarrassing.
Yeah.
Hee hee. My human is showing. That's a Y. Thank you. And then I filled in the wrong number because look, I had it labeled wrong and I filled it in wrong. That's why you got to label stuff correctly. Thanks, guys. I did that on purpose, you know? I was just checking to see if y'all were watching. Yikes. Embarrassing. Okay. We love it. But if we finish it correctly, plugging in all of our numbers where they actually should go, your equation is going to look something like this. Now, it's an equation. It's not in slope-intercept form. That's okay. Because in this form, we can still talk about the slope. If I wanted to put it into slope-intercept form, you'd have to distribute the 1 and add 85 to both sides, which we will worry about later. This is an okay equation of a line. Unless it asks you for a specific type of equation, you can stop right there. But let's interpret the slope here. What was my slope? What was the number I got for slope? 1. And what are we talking about with this graph again? What are we measuring? What's the x-axis? And what's the y-axis? Homework grade. So if my slope is 1, that means each homework this person turns in means homework grade goes up by 1. So there's a direct correlation between the number of homework assignments you turn in and your grade, which, LOL, is true. Real thing. Question for QuickBooks. I want you to raise your hand for this one, if you know it. What does this symbol mean again? Raise your hand. Don't say it out loud. I saw your hand first. What was it?
I forgot. No, but I knew it like conclusion.
It is a conclusion. Technically, what word? Therefore. Yeah, it's a conclusion. The word is therefore. Fabulous. You're going to see that a lot because I'm a mathematician. I get lazy and I use mathematician handwriting all the time. That's the symbol for therefore.
Therefore, each homework means grade.
Each homework you turn in means your grade goes up by 1. Oh, I'm sorry. You can't see. I'll raise it up. Therefore, each time you turn in a homework, it means your grade goes up by 1. We love that. Okay, now, so today we are not doing this entire thing. We're actually only going to be doing the next single problem. The rest of this notes will be for next time. So don't lose this, which is why it should be glued into your spiral. Before next time, I'm not creating extra copies. You'll have to write all of the rest of that stuff down on a piece of paper if you don't bring it back. Okay, but we're just going to do this last example. It's kind of a long example, So if you have really big handwriting, you might want to do this on a separate sheet of paper anyways. I'm just telling you that right now. There's kind of a lot of writing going on with it and not a lot of space. It's not a hard question, it's just got a lot going on. So this question says, the cost of parking in a parking garage in Chicago is represented by the equation y equal to 15x plus 20. First things first, that's an equation they gave us. Let's highlight it. We need this equation. It says y is the total cost in dollars, that's the output, yes, how much am I paying, and x is the time in hours. That makes sense because the amount of time that you spend in a parking spot, the more it costs, right? The longer you spend, okay. The table shows the total cost to park in a parking garage in Denver. So this black equation is Chicago. I will make Denver blue. So this whole table represents Denver. We haven't written an equation yet, we just have this information. The first question here says, which city's parking garage charges more per hour and by how much more? Okay, that's all we're not even going to read the second question just yet. Which city's parking garage charges more per hour and how much more? What does this word per mean? Multiply. And in Algebra 1, when you were writing equation and you saw the word per, where did you put that number? Was it your slope or your y-intercept? Slope, because it's a multiplied number. It's multiplied by x, which is where the per multiplied comes from. So we want to compare the slopes together. What is the slope of Chicago?
15.
The slope is 15. All right, so we already know the slope for Chicago. We need to know the slope for Denver. But I'm given values in a table. So what I'm going to do now is I'm going to teach you how to find the slope using your computer. By computer, I mean calculator. Last year, you would have learned how to do this on Desmos. It's the y1 squiggly line, mx1 plus b. Do you remember that?
Yes.
Okay, so we're not using Desmos this year unless you're doing it at home. When you go home, you remember all the things that your Algebra 1 teachers taught you last year because you can use Desmos at home. I'm going to teach you how to do all of that in the calculator. In fact, you have the instructions already on your desk. I will walk through the instructions. I'll show you on my, I can like pull up a calculator up there for me, but you're going to have to follow along with me. It's kind of button clicky, okay? Based on what we got out of the calculator, we were told that Denver's equation is y equal to 8x plus 27. Where did I get the 8 and 27 from, you ask? From my screen. 8, 27. A, B. Okay. So my question for you now, if we look at this equation and we have Denver's slope, what is the slope of the Denver equation? 8. So which city's parking garage charges more per hour? Chicago charges more. So we're going to say, therefore, Chicago charges more. And how much more? $7 more per hour. That's expensive. I hate paying for parking, period. Yes, ma'am.
So when we take tests and stuff, since we don't have answer choices, are we gonna have to like put the therefore?
You will have answer choices, and if you don't, I won't require it, but I'll allow it. But a lot of your tests will have answer choices. Quizzes and stuff, you can put the therefore if you like. You could forget about the therefore. As long as you answer my question, that's okay. Woo-wee! All right. Second part of this question says, after how many hours would parking in both cities cost the same? In mathematics, what's another word for same? Equal to, which means what we're going to do is we're going to take the equation for Chicago and we're going to set it equal to the equation for Denver because we want to know when they're the same or equal. Cool, great, awesome. What kind of problem do I have left here now when I look at just this part? Yeah, draw the line. We're going to solve this. If you were in my class last year, I used the box method a lot to solve these types of equations. I'm not doing that this year, but if you remember how to use the box method, you totally can. I'm not stopping you. Okay, but what we are going to do is we're going to draw a line down the center of our equal sign, and we're going to balance this equation out, which means we do inverse operations. What's the inverse of adding 20? Subtracting 20. So I'm going to subtract 20 from the left-hand side and the right-hand side. Why did I line up that 20 underneath the 27 and not the 8x? Because of the variable. Very good. Yeah, because of the variable. It doesn't have a variable, so I can't combine it with things with variables. My next line says 15x equal to 8x plus 7. I still need to balance this out. 27 minus 20 is 7, by the way. That's where I got that from. I need this 8x to move to the x side. What's the inverse of being positive 8x? Negative 8x. Great. These x's are the same, so I can subtract 15 minus 8. 15 minus 8 is 7. So this is going to be 7x equal to 7. The last thing I need to do is get that x by itself. It is currently multiplied by 7. How do I undo multiplication?
Divided by 7.
Divided by 7 on both sides. That's going to get rid of that front 7. And then all I have to do is 7 divided by 7 is 1. X is perfect. X equal to 1. Or 1x equal to 1. Now, what the heck did we do that for? What was the question asking again?
How many hours were parking in both cities?
After how many hours would parkings in both cities cost the same? So therefore, after 1 hour, they cost the same. So it's deceiving. Chicago looks like it's less expensive at first, but then all of a sudden it's just as expensive. That's going to be it for today. If you want to glue this into your spiral now, that's a good idea. Again, don't lose it. We're needing it next time.